So we're going to use this nice diagram from John Winter, his textbook on igneous and metamorphic petrology, to look at melting in a binary system. Binary because we have two components, albite plus and anorthite. These are two feldspars that can mix in any proportions, and because they can mix in any proportions, we call it a complete solid solution. And then we have some vertical and horizontal lines that we can use to help illustrate or augment the presentation. So what John Winter shows in his textbook is a bulk composition that is labeled as A. And when you have a composition equal to A, if it starts out as a solid, so if it's below the solidus curve, and that's this lower curve here, it would start out as a solid composition. And as we increase the temperature from some low temperature down here, it would begin melting when that blue curve hits the solidus. So we're starting here at a low temperature and increasing the temperature upwards until we hit the solidus at H. And that temperature H would be something between 1300 and 1350 degrees, maybe about 1340 in this diagram. Now, once we begin melting at composition H, what would happen is we're going to create a liquid of a very different composition. The bulk composition has an anorthite weight percent of 60%, but the liquid that's going to be produced, we would find that liquid by following this horizontal line over to the letter G, and that letter G, let's move our trusty vertical line, has a composition of about 22 weight percent anorthite. So notice that the liquid is very different in composition from the solid that we started out with. Those are bulk composition here, and the liquid looks very, very different. Now that liquid has just a tiny fraction of weight percent in the total system. So we have a system, a liquid that's very different in composition, but it's just a trivial fraction. As we hit a temperature of about 1340 degrees or so, we're getting just an infinitesimal amount of liquid over at G. If we continue increasing the temperature as we go from H to B, so that's the path that the bulk composition will follow. The bulk will increase in temperature from 1330 up to B. At B, it would be completely liquid, so that the system will be completely melted at a temperature of about 1480 degrees centigrade. To get from H to B in terms of the bulk composition, the liquid's going to follow this pink curve here from G to D to B, and then the solids will go from H to F to C. So how will that work? Well, if we pull some sodium-rich liquid material out of this bulk composition H, that leaves the solid residue a little bit richer in anorthite because some sodium has been removed. So that means the solid would move in this direction. It will be a sum of two vectors migrating to the right as we pull out sodium that's going into the liquid, and then going upwards as we increase the temperature by adding heat. And the sum of those vectors is this pink line here. So the solid that we would have after removing a little bit of liquid would be, let's say, over here. So the new solid would be just picking an arbitrary, let's pick an even temperature. Let's say we raise the temperature to 1400 degrees. Then the solid we would have a composition of about anorthite 71 weight percent, and then the liquid that would be in equilibrium with that would be about 20, maybe about 27% anorthite. So both the liquid and the crystals have become more calcium rich. What if we increase the temperature to 1450 degrees centigrade? Now we have a liquid that is pretty close to AN50, maybe about AN48, 48 weight percent anorthite in composition, and the crystals are a little above AN80, maybe about AN82 in composition. If we move up to this final melting temperature of about 1470 degrees centigrade, then the final crystal composition is about AN87 or so. And look at the final liquid. The final liquid now looks like the original bulk composition, as it should if we've completely melted the system, as we would expect when we reach this temperature here. then the liquid should equal the bulk composition.